Hey kiddos, excuse me. Today we're going to do Unit 5, Lesson 3. So we are moving on to talk more specifically about quadratics, okay? So let me get some pens here. This whole diagram is just going to help us with our vocabulary, okay? So let's start with this blue dashed line. That goes down the center of our graph. This is called the axis of symmetry. Okay, think about what symmetry means. Symmetry means that something is exactly the same on both sides. So it should look like it was flipped, okay, or reflected over that axis of symmetry. And so the equation that we use to find the axis of symmetry is going to be x equals negative b divided by 2a. And that's a b. Okay. Next, let's look at what is this? Ax squared plus bx plus c. This is a quadratic function in standard form. And then this down here, this equation is a quadratic function that is in vertex form. All right. So when we graph a quadratic, the shape that we get is called a parabola. Okay, and so a parabola will either look like this or it will look like this, kind of like a U, okay, or an upside down U. So that is a parabola. What about this spot right here? Let me do this one in green. This spot is going to be our y-intercept. And so our y-intercept is going to be located at 0, C. That's what the ordered pair would look like. Notice the C in standard form, okay, is where we get that information from. And let's see, we've got two more. Okay, so this spot right here at the very bottom of the parabola, okay, at the bottom of the parabola, this point here is called the vertex. So this is called the vertex, and in a parabola, the vertex is either going to be a minimum or a maximum. Okay, and so when I refer to the A value for the vertex, the A value is right there in my standard form, and it's in front of the parentheses in my vertex form. And then we have just one more thing to talk about, and I've already colored them on your graphs. Okay, where the parabola crosses the x-axis, this is called, well, lots of different things, okay? So it is the x-intercepts, but there are other names that we use for them. So they could be called the zeros, the roots, the solutions, okay? We will work more with these in a little bit, not in today's lesson, but we will definitely get to those. So this is all of our vocabulary that has to do with key features of quadratic functions, okay? So let's go ahead and dive right into an example, okay? Let me move these pens out of the way. So let's look at the parent function. A parent function is the most simple version of any kind of function. Okay, so the most simplified version of a quadratic. So in order to graph this, what we're going to do is take these x values and plug them in for the x. So here we go. -2 squared is 4. -1 squared is 1. 0 squared is 0. 1 squared is 1. 2 squared is 2. Okay, so now what we're going to do is we're going to plot each of these ordered pairs. -2, 4, -1, 1, 0, 0, 1, 1, and 2, 2. We're going to plot these ordered pairs. So let's go ahead and do that. -2 up 1, 2, 3, 4. I think I did that correctly. Up a little bit. -1 up 1, 0, 0. +1 up 1, +2 up 4. And so notice that I get this nice U shape. I get this nice U shape when I graph it. Okay, and I do just want to point out that the vertex here, well, the axis of symmetry first goes right through the vertex right there. Okay, and so the axis of symmetry is located in this situation at x equals 0. Oh, and actually they're asking me questions about my graph over here. So let's take a look at it. So what is the equation for the axis of symmetry? It is the x value of the vertex. So x equals 0. Does this have a minimum or a maximum value? Well, this is the lowest point of the graph. So this is going to be a minimum value. Okay. What are the x and y intercepts? Well, in this case, both the x and the y intercepts are at 0. So the y-intercept and the x-intercept. I'm trying to keep my color coding. So here we go. The x-intercepts are at 0. And there's only one of them. And the y-intercept is also at 0, 0. And there's only one of those. Okay? And now let's talk about what is the domain and what is the range. Well, the domain is the x values. The domain is the x values. And so left and right are my x's. And I can go, every parabola can go left and right infinitely. Okay, so we say that the domain is all real numbers. And I use this letter R with like a double line, okay? The range comes from the vertex. It comes from the vertex, okay? The vertex is located at 0, 0. And so this is going to be greater than, the y values are all greater than or equal to the y value of the vertex, which is 0 in this case. Okay, let me zoom out a tiny bit so we can see everything. Alrighty, so this is the parent function for a quadratic. And this is what it looks like, and these are what the features are, okay? And so the coordinates of the vertex in this case were 0, 0, 0, 0, and I used the y value of the vertex to give me my range. So don't forget about that, okay? All right, let's take a look at number 2, another example of graphing using a table. So I'm going to zoom in here. Okay, what we need to do is to plug in these x values everywhere there's an x in this function. So here's what I'll have. Negative 2 squared plus 2 times negative 2 minus 8. And then I'm going to simplify that. So I'd like for you to pause this video and then fill in all the rest of this table, okay? And simplify it. So negative 2 times negative 2 is a positive 4. 2 and negative 2 is a negative 4. So I have 4 minus 4, which is 0, and 0 minus 8, which is negative 8. So I want you to do that for all the rest of these x values. All right, so I have finished filling in my entire table. If you needed to use a calculator to help you simplify any of this, you could do that. That's fine. And so what I'm going to do now is I'm going to take the information from this table, the ordered pairs, negative 2, negative 8, and I'm going to go ahead and start to plot this information, okay? All right, so negative 2, negative 8, 0, negative 8, negative 1, negative 9, 1, negative 5, 2, 0. So here is what I have. Here's what I have currently. I want you to know that you can do a mirror image of the points. So from our lowest value right here, okay, that would be our axis of symmetry. And so these ordered pairs are going to be equidistant from the axis of symmetry. So 2, so go on this side 2, and then you could fill in that point. This is over 1, 2, 3, so go 1, 2, 3. Okay, so this is what the rest of it would look like. And then just do your best to create a nice smooth curve. And don't forget your arrows. All right, let's go ahead and from this picture, let's start talking about our specific information, okay? What are the coordinates of the vertex? Well, the vertex is this very lowest point right here, which means that this is going to be a minimum value, and its location is at negative 1, negative 9. Okay, so that is the value of the minimum, the vertex. What is the equation for the axis of symmetry? Well, this line goes directly through the vertex at negative 1. So this tells you the equation for the axis of symmetry. Okay? All right. Now, the x and y intercepts. the x and y intercepts. These are going to be different this time. So I will have 2 x-intercepts, and I will just have 1 y-intercept. And they will not be the same values this time. So the x-intercepts are where they cross the x-axis, okay? So right here and right here. All we're doing today is identifying them. So those are my x-intercepts, and I'm going to write them as ordered pairs. So negative 1, 2, 3, 4, comma 0, and positive 2, excuse me, comma 0. All right, now my y-intercept is right here on the y-axis. I did that a little off, but that's okay. And it is at 0, comma, negative 8. So that is the ordered pair for the y-intercept. Okay, now I need to identify the domain and the range. So the domain is always going to be, for a parabola, all real numbers. The range is what we really want to pay attention to, okay? So the range is always going to be referring to the y value of the vertex. So this is a minimum, which means that the graph can go up and up and up forever. So it's going to be greater than or equal to negative 9, the y value of the vertex. So the vertex really does tell us quite a bit of information. Okay, so I get that from the vertex. All right, so we've just done 2 examples where we had to create a table so that we could graph them and then use the picture to identify all the information. Okay, we don't have to do it that way every time. There are some other things that we can do. So let's go to the second page of our notes. Okay, so steps for graphing without using a table. So first we're going to determine whether the graph should open up or down. Then you can do these 3 in any order. You want to find and graph the y-intercept, find and graph the vertex, find and graph the axis of symmetry. Okay, so those can be done in any order. All right, step 5, reflect the y-intercept over the axis of symmetry. We know what a reflection is, right? Because we've already worked with reflections this year. And then step 6, connect the points with a smooth curve forming a parabola. So we're going to go ahead and take a look at example 3 here. We're going to graph this by simply identifying the characteristics from the standard form, okay? So to determine if this opens upward or downward, does it open up or does it open down? I need to take a look at my A value. So A is a negative 1, which means that this is going to open downward. When it opens downward, it has a maximum value. Okay? Let's find the axis of symmetry next. So I need to know my A value and my B value. Well, A is -1. B is a +2 right here in the center. So I'm going to plug these into this axis of symmetry formula here. So X is going to equal -2 divided by 2 times -1. So here's what I have. 2 divided by -2. We'll just say there's a -2 down there, right? And then I've got 2 negatives, so that's going to equal a +1. Okay, so my axis of symmetry is at +1. And I'm going to continue to label this blue for us, okay? X equals 1. Now, how do I identify my vertex? Well, the axis of symmetry is the X value of the vertex. So I'm going to go ahead and just bring that down. And this will be an ordered pair. So what I'm going to need to do is to just plug in this number. So negative x squared plus 2 times x minus 4. So I need to plug in the x value of the axis of symmetry, which is just a 1. So this is 1 times 1, and then bring down the negative, plus 2 times 1 minus 4. And this will be -5 plus 2, which is -3. So the y value of the vertex is at -3. All right. Next thing that we want to do is identify the y-intercept. The y-intercept. If you remember from our vocabulary sheet, the y-intercept is simply the value of c in the standard form equation. So my y-intercept is 0, -4 because c equals -4. Okay, so now we are ready to go ahead and plot all of these points and to graph this based on just the features. Okay, so this is the vertex. Alrighty. So let's plot these points. My vertex is located at +1, -3. Okay. And that's going to be, and then my y-intercept is at 0, -1, 2, 3, 4. Now let me go ahead and draw my axis of symmetry, because what we need to do is reflect the y-intercept over the axis of symmetry. And that will help us to see that this is going to be graphed this way. Okay, and that's it. We just graphed this using key features or characteristics that we can gain just by looking at the equation of a quadratic function in standard form. Today's focus is truly on standard form. All right, so let's switch it around now. What if I give you a picture? Can you identify the key features? The key features. So starting with my y-intercept, let's go ahead and find that location, which is right here at 0, 3. Alrighty. My vertex my vertex. So I need to identify the vertex before I can find the axis of symmetry. The vertex is right here at -2, -1, -2, -1. Whoops, I put that in the wrong spot. All right, but the x value of the vertex is going to be the axis of symmetry. So I'm just going to draw this dotted line that goes right through the vertex. Okay, so x equals -2 is going to be my axis of symmetry. Where are the zeros of this function? Where are the zeros? Okay, the zeros are located on the x-axis. Okay, these are, remember, the x-intercepts. And so they are located right here at 0, -1, and at 0, negative, let's see, 1, 2, 3. Okay, so 0, 3. And now, finally, I need to determine, is this vertex a minimum or a maximum? Well, because the graph is going up, it goes up, so I have a minimum here. Alrighty, and so that is all the key characteristics by just looking at the picture of a parabola. Let's do one more. Let's just do one more, like example 3, okay? Okay, graph the function by using the characteristics. So, starting with the value of a, this is a negative, so it will be opening down. A is less than 0, so it opens down. The axis of symmetry. Well, let's start by finding my vertex, shall we? Well, the axis of symmetry is going to be this formula. X equals -b divided by 2a. So -4 divided by 2 times -1. What's -4 divided by -2? That is 2. So the axis of symmetry is at x equals 2. Now for the vertex, I'm going to use that 2, and I just got to find the y value now, okay? So the y value, I'm going to plug 2 into this quadratic equation and simplify it. So I've got -2 squared plus 4 times 2 minus 1. That's going to give me -4 plus 8 minus 1, which is 8 minus 5, which is 3. So there is my vertex. Okay. And finally, for my y-intercept, the y-intercept is the value of c. C equals -1, so the y-intercept is at 0, -1. Okay. The only thing that I left out of this was really all the different highlighting. Okay. So if you just want to keep up with that, you're welcome to. The axis of symmetry is blue, at least the way that I've done it. The vertex is yellow. The y-intercept is green. Okay. All right, now let's go ahead and graph this. So I'm going to go to the y-intercept at 0, -1, 0, -1. Then I'm going to plot the vertex. 2, -3, 1, 2, 3. I'm sorry, 2, +3. 1, 2, 3. And then I'm going to draw the axis of symmetry at x equals 2. Okay, so now I can reflect my y-intercept over the axis of symmetry. And then I'm ready to connect my 3 points with a nice curve. Well, I do a really bad job at the curves. All right, and that's it. So I have graphed this quadratic function. All right, kiddos, that is it for today. Just please, please, please definitely remember this information here, okay? So your vocabulary and then your steps for graphing without using a table. Without creating a table, you can do things a lot faster, okay? All right, kiddos, until next time.